So I wanted to make a video on how to get a BMW E90 instrument cluster working in Assetto Corsa. A few people have already done it online, but I couldn't find any step-by-step instructions for people who are idiots like me. So without further ado, let's get right into it. To start off with the parts that you'll need, I've also included some links in the video description below. The first thing you'll need, of course, is going to be an instrument cluster. You can use one from any E90, E92, E93 BMW 3 Series. I ended up getting one out of a 335i just because the tachometer reads up to 8,000 RPM, and it was quite a lot cheaper than going with an M3 one. Next, you're going to need an Arduino. You can use a Pro Micro, an Uno, a Mega, or anything similar. I ended up going with an Arduino Uno R3 since my local electronics store had one in stock, and the assembly is quite a bit easier than using something like a Pro Micro. You'll also need a CAN bus shield to give your Arduino CAN bus capability so it can send the signals to the instrument cluster. I use the one linked in the video description, but you should be able to use any CAN bus shield with an MCP2515 CAN bus controller. You'll also want to grab some jumper wires to connect to the pins on the back of the cluster, and a 12-volt power adapter to power it. The next thing is entirely optional, but I also 3D printed an enclosure I found on Thingiverse. Full credit to Apol for designing it. Now it's time to assemble the unit. Using the Uno, it's pretty easy since all the pins directly line up. Basically, you just connect the CAN bus shield on top of the Uno as shown in this picture. We're only going to use this terminal on the CAN bus shield to send the signals to your cluster. Basically, there's one wire for CAN high and one wire for CAN low. On the back of the cluster, there are 18 pins across two columns. On the left side are pins 1 to 9, and on the right are 10 to 18. We're only going to use 4 pins, pins 6, 7, 9, and 18. Connect the CAN high wire to pin number 6 and the CAN low wire to pin number 7. Then connect the positive wire from your power adapter to pin number 9 and the negative wire to pin number 18. Now to program the Arduino, you're going to want to download the project files linked in the description. Credit to TechSouSick, hope I'm saying that right, for putting this all together. So click on code on the website, then download zip, and once it's finished downloading, extract the files. Next, you're going to want to download and install Microsoft Visual Studio Code, and once it's done installing, launch the program. We are going to need to add the Platform IO extension to be able to open up and use the project file. Click on the Extensions tab on the left and then search for Platform IO and then install it. When that's done, click on the Platform IO tab on the left, and under PIO Home, click on Open, then click on Import Arduino Project. In the Select Board field, we're going to pick Arduino Uno. Then you want to navigate to the project file we just downloaded and click Import. Now, we are going to want to make a few changes. Firstly, since we are using an Arduino Uno instead of a Micro, we're going to change the environment and board from Micro to Uno. Then, under SRC, you want to select canbus.cpp. We're going to want to make some changes here to the speed that the Arduino sends the signals to the instrument cluster. I'm not sure why, but by default it's set up to send the speedometer signal every 70 milliseconds and the RPM every 200 milliseconds. I tried running it as is at first, and I found that there was quite a noticeable lag between the cluster and like the in-game RPM. What we're going to do is copy the send speed and the send RPM strings, and then paste them at the top here so that they're being sent every 10 milliseconds. Then delete them from where they were previously. You can actually get rid of this whole entire section. I also changed this value from 10 milliseconds to 1 millisecond. You can pause the video here if you want to quickly double check just to make sure your code looks the same and you didn't make any typos. Once that's done, then we're going to click on the check mark at the bottom to compile the code, and if you did everything correctly, it should say success. If you get any errors, just double check your code and make sure you didn't make any typos. Then we're going to click on the arrow to upload the code to our Arduino. Again, it should say success once it's done, and once that's done, you can exit out of Visual Studio Code.
Great success!
Now, if you don't already have SimHub installed, you're going to want to download it, extract the zip file, and install it. If it's your first time using SimHub, you're going to want to make sure to configure Assetto Corsa. Now, you're probably not going to see custom serial devices as an option on the left, as I believe it's disabled by default. To enable it, you're going to want to click on Add/Remove Features and then toggle Custom Serial Devices to On. Now click on it, and then under Serial Port, you want to select your Arduino. Make sure that the baud rate is set to 115200. And then under Update Messages, make sure to set it at 60 Hz and then click on Edit, then click on Use JavaScript. You then want to navigate to the project file you downloaded and open up Assetto Custom Protocol with Notepad. Then select all, copy, and paste it into the text box. Then click OK. I also recommend buying a SimHub license, as I think the free version is limited to 10 Hz or 10 frames per second for the telemetry data, whereas the licensed version can actually go up to the 60 Hz. And you're done. You can minimize SimHub and launch Assetto Corsa, and your cluster should now be working. Once you've confirmed that everything works, I do also recommend using some hot glue or some quick-set epoxy just to secure all the wires in the back so they don't work themselves loose. If you found this tutorial helpful, please give the video a like, and if you have any questions or suggestions, please leave a comment below.